Hi and welcome to Math Pre-Calculus 20, section 5.3, solving radical equations, example 3. Alright, so this one we've got a pretty tricky looking radical equation here. So solve 7 plus 3x, or square root of 3x, equals square root of 5x plus 4 plus 5. And in this case, x has to be greater than or equal to 0. So that just means that we don't have to worry about the restrictions. It's already restricted for us. And then it wants us to check our solutions. Okay, so looking at this one, the first step we want to do in solving radicals, or solving radical equations, is that we want to isolate the radical. Well, in this case, we've got a radical, we've got a radical. So is it going to be possible to get just the radical on one side? Well, no, it's not going to be possible because we have more than one radical. So in this case, we can't do that first step. So this one's pretty tricky. So what we could do, though, is at the very least get all of the numbers on one side. So I'm going to subtract this 5 over. So I get 2 plus square root of 3x equals square root of 5x plus 4. Okay, so then after we isolate the radical, which we can't do in this case, right? So we can't isolate the radical. So since we can't do that, we're just going to go ahead and square both sides like we would anyway. So square all of that, square all of that. So just watch here that we're squaring the entire side there. So it's not 2 squared and square root of 3x squared. It's the entire 2 plus square root of 3x squared. So then when we work with this, well, that means we've got a binomial squared, right? This is actually 2 plus square root of 3x times 2 plus the square root of 3x. So that becomes 4 plus 2 square root 3x plus 2 square root 3x, so 4 square root 3x when we combine the like terms in the middle. And then plus, well, when we square root of 3x, we just get 3x. That's the point. Okay, on this side, well, it works out perfectly. We just have 5x plus 4, right? That's why we do that. Okay, now we get a question similar to what we've been dealing with previously. So what we want to do now is isolate the radical, right? So here we want to isolate the square root. So in this case, we can subtract 4 over. So those are actually going to cancel on both sides. We can subtract 3x. So we get 4 square root 3x equals 2x. And then we don't really have to. We could divide both sides by 4. Let's not divide both sides by 4 so I can just show you how that works. So at this point, we can square both sides. So if we square both sides, we're squaring all of that. We're squaring all of that. And so we have 4 squared, which is 16. And then we have square root of 3x squared, which is just 3x. So the key there, right, is make sure that you've done that squaring of the 4 and the squaring of the square root of 3x. And then on this side, we have 4x squared. So the number 2 squared and the x squared. Okay, now we're just working towards isolating the x's. So in this case, we have 48x equals 4x squared. Okay, this is a quadratic, so with a quadratic, we're probably going to solve it by factoring. So we can go 0 equals 4x squared, take away 48x, and then to factor that, well, it's not a trinomial, it's just a binomial, and it's not a perfect square. It's got a GCF of 4x, and then we're left with x minus 12. So then we have, right, the two possibilities of 4x equals 0 or x minus 12 equals 0. So x equals 0 is that one, x equals 12 is that one. Okay, first thing we should check with our solutions there is, do they follow that restriction? Well, it told us in the first place that x is greater than or equal to 0. Are these both greater than or equal to 0? Yes, they are. Right, so that's good. Next thing we should do is actually check that these solutions work in the equation. So to check that, right, we just go to our original equation and we plug them in. So we have, just erasing some of this here, and I'm just going to plug them in there. So that's 0, that's 0. So then we get 7 plus 0. Is that equal to, that becomes square root of 4, because it was 5 times 0 plus 5. 7 equals 2 plus 5. Is that 7? Yes. Okay, so that solution, first solution here works. Second one, right, we want to check to see if 12 works. So plug 12 in there, 12 in there. So I get 7 plus square root of 3 times 12, so 36. Is that equal to 5 times 12 is 60, so square root of 64 plus 5. So this is 7 plus 6. Is that equal to 8 plus 5? And yeah, they're both equal to 13, so that solution works as well. Right, so we want to take that time to check them because there are many instances where we get what's called an extraneous root, where they don't actually check. You can get the solution, but they don't check. So it's really important with radical equations to check them. Okay, key thing to this question here was the fact that we had, right, two radicals, so we couldn't isolate the radicals, so we ended up having to do that FOIL part here, if that's what we want to call it, the FOIL part on that radical to get all of this. So it's pretty tricky, but just follow the math that you know how to do, right? There's nothing really new here, it's just kind of radicals thrown in there. All right, thanks for watching.